Bismillah wa salatu wa salam ala Rasulillah. Welcome all to the statics course GE 201 fall 2021. Okay, so last time we introduced the course, we showed the syllabus, right, and then we showed the mark distribution or the grade distribution, right, and we recorded that first meeting and we sent the record to the WhatsApp group that is allocated to the students who is taking in section MA2. Okay, so I'm teaching section MA2. So we still have problems on the number of students. Hopefully that problem will be solved soon. Anyway, just to continue, last time we started by mentioning the difference between science and engineering, and we followed explaining the professional and ethical responsibility. We introduced the mechanics and what type of courses that belongs with mechanics in engineering or in mechanical engineering specifically. And then we showed a couple of basic concepts in static, and we stopped in the scalar versus vectors. Okay, so just to give you whoever like missed that meeting, so we said that ethical is an important issue for engineering sector, where engineer needs to be honest, like knows the importance of whatever he's doing. He should be fair. He should do whatever is proposing in terms of design in equity for male and female, and also for disability of peoples, right? People who has disability, and also to dedicate that this design will be safe and will not harm the public health and should take care about the welfare. Okay, we mentioned there is a list of different standards. They have different codes in ethics in engineering. For example, Institute of Industrial and Systems Engineering or engineers, and then also ASE, American Society for Mechanical Engineer, right? This is abbreviated for American Society for Mechanical Engineers, right? So Code of Ethics and Engineers. So a list of ethics that you need to be really aware of if you want to get involved in any design, something that will be dealing with the people or will be presented to the public. We mentioned that the mechanics is the science or the physical science that deals with the effect of forces on objects. We are talk about forces. I would say loads. It's better word in English. Loads, ahmal, is better than forces. But basically, the things that in statics or static books, you will see that most of the time talk about forces because we are dealing on the system that is in equilibrium, and that system will receive different type of forces or torque or moments that will not lead to a motion. If it is in motion, that means imbalance. The force is imbalance, so that is dynamics. And mechanics is divided in three categories: rigid bodies, deformable bodies, and fluids. Can anyone define for me rigid bodies? Have you ever heard about this terminology, rigid bodies? What does that mean? Anyone? Guys, I'm asking now. Hello? Can you, are you with me, guys? Can you hear me clearly? Hello?
ايه نسمعك دكتور. الريجيد باديس اللي هي
Okay.
دكتور المواد الصلبه الثابته اللي ما تتحرك او انها يعني تكون صلبه يعني دكتور.
Not really, and not exactly, but close. Anyone else? Anyone else? Yes, are close. Rigid is not true. When you hear the terminology in mechanical engineering, rigid, يعني the common sense for like if you translate it, it is like a tough, it's a solid object. No, but from engineering point of view, or specific from mechanical engineering point of view, rigid, it means it is this part, it is non-deformable part. يعني هذا الجسم يتحرك اما ككتله واحده او يكون ثابت ككتله واحده، ما يحصل له deformation. there is no deformation، ما يحصل له تشوه. واضح؟ if it reaches to a deformation, so it has elasticity، يعني عنده مرونه. So and maybe it depends on the type of materials, so ductile or brittle material, as you're going to take inshallah in the next courses in mechanics of material and material science inshallah in the future. So if it is deformed, it means that it has now reached to like a stress strain diagram. So I'm going to study the deformation and see that this part it will be failed or not، يعني هل يحصل له انكسار او لا. واضح؟ If you talk about the matter of the state of the matter of that object, is it solid or fluid or gas? So now we are talking about the solid mechanics or fluid mechanics. So this is why also the fluid here is one of the categories in mechanics, right? So this is the state of the matter، حالة المادة. Okay. So now this is about rigid. Let me ask now another question. What is the difference if you look like here? Underneath the rigid bodies, we have statics and dynamics. What is the main difference between these two classifications? Anyone?
Doctor.
Yes.
Dynamics is related with motion of materials.
Okay.
But statics related with the material itself.
What do you mean? What do you mean by material itself? Okay.
The forces applied to the material without motion.
Okay. Yeah. Mention the word forces. Okay. Or in general loads. يعني forces شباب. Force. The translating of this word, it is قوة. ولكن in mechanical engineering we will talk about loads. الأحمال. We have different type of loads. يعني ممكن يكون قوة، ممكن يكون عزم دوران هو تورك، أو يكون مومنت اللي هو الدوران المحوري، أو يكون عندنا بريشر ضغط، أو يكون ثيرمال لود يعني يكون أحمال حرارية زي ما حتاخذون إن شاء الله في المستقبل، يعني كورسات تدرس اللي هو الحراريات. يعني إن شاء الله يعني هذه الأشياء يعني في الهندسة يعني it will إن شاء الله collect all whatever you learning and then will be really a real mechanical engineer إن شاء الله. But for now, to be more specific, when you define the difference between statics and dynamics, we have to talk about the forces, right? And then you mentioned that if you have balance, that the system or the object or the part or the particles or whatever you have in terms of elements, it is under equilibrium تحت الاتزان due to that forces. يعني هذه الفورسز ما أثرت إنه يتحرك، فهذا static. أو هذه القوة كانت مؤثرة بالتساوي بحيث إنه هذا الجسم يعني this particle will move in a constant speed or constant velocity. And we know inshallah today the difference between speed and the word velocity, right? So that means still static. However, if there is an acceleration, that means there's imbalance in the forces, so that would be dynamics. Clear, guys? I want to be crystal clear about this because I want you to have the sense about this. Why I'm studying statics, why I'm studying dynamics, why I'm studying fluid mechanics, and then why I'm studying mechanics of materials. So you have to have the sense. Okay? Clear, guys? Okay. So now the formal bodies, you're going to study this. You study the deformability or the deformation of that material in order to study the failure mode of that part, right? And then fluid mechanics, it have two different type of fluids, either incompressible or compressible. Each one has its own characteristics. Okay. So here is specifically what is statics because it's related to our course, right? So statics, like it concerns with the equilibrium, as I mentioned, right? Or the velocity is constant. And if you look here for these 2 points that I included in the slide, let me use the pen. So force, why do I need to know about force? Because the force are responsible for maintaining balance or causing motion, right? Or change the shape. This is first one. Balance, it means static. Motion means dynamic. Change the shape means mechanics of material. ميكانيكا المواد. واضح؟ Okay. What is the motion? Motion and changes in shape لما يكون عندنا حركة وتغير في الجسم are critical. Why? Due to the functionality of artifacts in the man-made world and to phenomena in the natural world. If you study the motion, you are studying about the dynamics, right? And then how you control this motion. What is the mobility of that motion? What is the degree of freedom in that motion? Okay? And then if it's study the changes, right, we want to study how, or maybe we study the efficiency or the sustainability of that system to sustain for that exerted forces. So what is the amount of deformation, right? So does it exceed the strength of material, قوة تحمل المادة, or it would be on the region that would be acceptable and there is no deformation, or they call it exceed the limit of that material, the strength of that material. واضح? So the role of statics is essential for many branches in engineering. This is why we study statics. So I mentioned that in the beginning of that lecture, previous lecture, and also I mentioned that we have 2 steps or 2 main stages in statics, right? So we study we need to know the known forces, and from the known forces we seek to determine the forces within the part, and then the forces between that part we can gain it by answering the question and address the question design, right? If you want to learn and study the fracture of that material. So static, we learn how to use one principle to relate unknown forces to known forces. You know that, I'm sure that all of you heard about the Newton's laws, right? قوانين نيوتن للحركة. We'll inshallah look at it today, inshallah. So basic concept I was mentioning about the last time. So we need to know about the space, X, Y, Z, in order to determine the position of any particles or object, right? Or body, if you like. So, and there is a different distinguish between particle and rigid body. Okay. So here's the length and mass. You know that, and then you know this SI unit, right? We have different standard of units. We have the international unit, SI unit, or the British unit, US unit, right? And I mentioned that we have length, time, mass. This is the primary units for الطول والوقت والكتلة. Meter, second, and kilogram. Okay. I'm sure that this is not new for you. You have taken it in the physics. And here's the space. So here we can determine the position of any objects or any elements or any particle. So just to get back to the previous slide. So particle is a body of negligible dimensions or size, and rigid body, as we define it, is non-deformable body. Okay. Sorry. Okay. Space X, Y, Z, and do have also a rotation around this axis. So we have 6 degrees of freedoms in motion, right? So to determine the position, I need to have different measurements, linear measurements and angular measurements. We can divide it by angle and a linear measurements. Okay. So we stopped here last time. So scalars and vectors. Can anyone tell me the difference between scalars and vectors? Anyone?
دكتور السكيلر اللي هو يقيس الماجنتيود just والفيكتور اللي هو يقيس الماجنتيود and direction.
Nice. Give me an example for this and this.
يعني مثلا يا دكتور الفيلوسيتي الاكسلريشن هذه كلها فيكتورز لانها اتجاه وماجنتيود. اما
ممتاز.
الفوليوم اما زي الحجم او الماس كل هذه ماجنتيود جست.
Okay, that's good. That's good. Thank you, Abdurrahman. Excellent. Abdurrahman Al-Sharfa. Jazakallah khair. Okay, so I think your colleague, it's like critically. I mean, he explained it really clearly, right? Sorry, guys. So scalar quantities only is a characteristic of a magnitude, right? So we are only concerned about the magnitude, القيمة المطلقة, right? But the direction and magnitude, so it means that we are concerned about vectors, right? Some quantities in vectors is the forces, right? The forces, القوة, or velocities, or accelerations, as your colleague mentioned, right? So all of this, they are vectors because we need to define them in space. So we use like a vector. We use an arrow. We use like an arrow, يعني أسهم, as it's a vector, wherein the arrow here, we mean by this arrow, هذه الأسهم, just a representation, يعني فقط تمثيل للقوة, ولكن we cannot see velocity, we cannot see, يعني we cannot sense it. So it is not tangible. It's not, يعني we cannot, there is no an actual shape of velocity, no actual shape of displacement, no actual shape of acceleration. But in order for engineer to see things, so we prefer to do diagram, to free body diagram. So to represent things, in order to solve it in paper, right? So we need to represent things use an arrow. Clear? So just an arrow. So any arrow, as you're going to see inshallah next slide, so it has a sense. So this is sense of direction, and then it has a length, right? So I'm going to show it also in the other. And then there has the point of starting, and the head, it is an arrowhead, they call it. And then the point also of application is really important, where this arrowhead will be in contact with that object, right? So if you are representing a displacement, right, of, for example, this particle A moving from A to B, right, so I can represent it with this vector, right? I say this is this vector, or this particle goes or displaced, okay, from this point to other point, so I can represent it, and this is the magnitude, and here is the direction, right? And then I can define it with the x, y, z coordinate. This is x, y, right? And then I can, with the x-axis, I can define the theta angle, right? Clear? Simple, right? So there is something called components, right? We know that in any vector has a component in x, y, is in two-dimensional space, and x, y, z in three-dimensional space. You learned this in physics, and so we'll cover it today. And then there's something called rectangular components, where we have the two vectors, the component of that is perpendicular to each other, right? And then we have the sum of two forces. It is, we call it resultant forces, right? Suppose that I have this particle, right? So this is particle A. I'm exerting on forces in this direction, right? And then another forces in this direction. So this is F1, right? This is F1, and this is F2, right? Sorry, guys. Right? So I need to do a parallel for that one, for F1, and a parallel for this one, and then I can find the resultant. Right? So يعني القوة المحصلة, and this is how you calculate it. يعني let me warn you guys, in textbooks, يعني في الكتب, right? You'll find that they write this in a bold face, right? So in the bold face يعني بشكل تخين, واضح? They mean this is a vector. But when we write it, we always, in handwritten, we say that if would be something like an arrowhead in the top. So just to mean that this is a vector. Or maybe some of the handwritten, they write that force 1, and then they put underline. Okay, you find that different people, they use either this way of writing. Okay, clear, guys? ايش معنى محصله؟ يعني خليني اوضح لك اياها. يعني simply يعني to find the resultant if you are this person F1, you have this amount of force on this object or this particle A, and then your colleague has this amount of force, right, F2, and he's pulling in this side and you are pulling in that side. It means the particle will have a combination due to these two components and moving or be unsettled if it is fixed, right? The tension or maybe the movement will take place on the resultant direction. يعني this is logically, take it in your home, hold the particle, put like a small ball, and then have a rope or a piece of wire in one side and then the other side, and try to pull it. You'll find that this object will move towards you in the resultant direction. واضح يا شباب؟ اعتقد انه هذه واضحه. يعني this physics. واضح يا شباب؟ يعني to simplify our calculations we find the resultant. واضح الفكره؟ تمام. clear. Nice. So also inshallah next lecture we'll talk about in more in force and force components, but just I presented it here. So force is the action on body, not of body. Is the action on body is the action of one is the action of one body on another body, right? So what does that mean? It means that if I have, for example, this particle, it is in this place, right? And then I have another particle is in this place. So is there any forces between this? So there is a gap between them. Is there any forces? If I want to do the body diagram of this, let's say this one, let's say it has a force in this direction, right? Or if you like, I would say, okay, these two objects, they are on table. The only force they have their own weights, mg. So this is mbg, and this is the weight of this one. So wb. So w sub a, it is m a, right, g, right, acceleration. Sorry, it's يعني we خليناها يعني they're close to each other. Just to be more clear, so we have object A and this object B. They are on table, for example, or on the ground. So the only forces affecting them, it is only the weight, right? Their own weight. So this is A. So this is particle B. So is there any forces that it will affect these two particles between each other? No forces, right? Because they are not in contact. واضح? They are not in physical contact. There is a gap here. So only the weight of B and the weight of A, which is due to the gravitational force, it will affect this. A has an affection on the ground, and also similarly for the particle B. Clear, guys? Simple. يعني has simple physics, guys. يعني this is really basic thing. However, another scenario, if you have, what do you mean analysis? Okay, let's say that we have here a ground. I have one object A, and then I have another object on top of it. This is B. So the weight of object B, it has an effect on A, and the weight of A, it has an effect on the ground. And the combination weight of the two of them, it has an effect on the ground. Clear? And if they have physical contact, so they have the force effect will take place. But if they are not in contact, there will be no force between them, between the two objects or two bodies. Clear, guys? So we know that the force is a vector quantity, So it has a magnitude and has a direction. Simple, right? So this is how we're gonna find the resultant, right? So the square root of the forces of x. For example, here, if this is f, right? So I find the components المركبة in the x-axis and the component in y-axis. X-axis. Can anyone tell me? Let me see, like, your knowledge. Can anyone tell me what does this letter I means, small I means, and small j means? Anyone? Let me see your knowledge. تفضل يا عبد الرحمن.
دكتور الاي تدل انه في اتجاه اكس والجي تدل انه في اتجاه واي بوزيتيف واي.
Okay, what does it mean also? Yeah, you are right, but what does it mean? So what I means, what j means, and also in if you have a three-dimensional, so this is z or z, right? And this is will have k, small k. So what does also small k means? You are right. You are right. Okay. So what is the like the terminology for this? What is the what word we are using to characterize this letter? We say this is a unit vector. We call it unit vector. هي وحدة واحدة متجهة في كل الإحداثيات في الإكس أكسس في الواي أكسس في الزي أكسس. يعني هذه عشان تعرف، لأنه نحن نعرف إنه any vector we can be defined with its any unit vector multiplied by, so any vector, just let's say I'm using handwritten, so any vector, so any force, so F, so just if I put arrow in the head, that means vector, right? It can be defined by a unit vector and times the magnitude. Clear? So this is, you can see clear here, right? So this is a component. So any vector in the space can be divided into components in x-axis, y-axis in the case of two-dimensional space, and in case of three-dimensional space, it is x, y, z, right? So in three-dimensional, just we add one more term here. We said f is vector, sorry, magnitude. This is vector. This is bold. Watch out. This is a bold face. Hey, this is not non-bold face. And we write f sub x, means the component in x-axis multiply the unit vector I vector. So it is in bold form. So this is I written in hand. Some people they write it I with and hat like this, or some people they write it I with the vector, or some people they write I under like line. And different way of writing it. Clear? واضح يا شباب؟ يعني like this support, and they have this rope, and the force is exerted here. If you look at from this side, if you look at from this side, right? If you look from this side and you want to analyze this and put it in 2D, I can, okay, this rope, the forces is in this direction, so 2D, so I can define the coordinate, the Cartesian coordinate x, y, z, right? So whatever, maybe you have this x, y, z, right? So let me be clear here. So here x, y, z. So here is x, here is z, y. Sorry, this is x and this is y. So you can see this is in this direction, right? This force in this direction. So I can find the components. So here it's x component, and here it's y component of this b. So this is bx. Here is by. Easy, right? You have taken in this. Easy. Okay? Any questions? Simple. Simple. Okay, Newton's law. You know this. I'm sure that you are familiar with this. And now this is يعني fundamental things for you guys. You know this. Alhamdulillah, from secondary school, we know this. First law, it is like there is sigma f equals 0. As you can see here, if you have a wind and then the friction, So all of them, they have zero effect on, for example, the car or the object, whatever. As this, they have the same direction, same magnitude, so it means sigma f equal 0. Sigma f equal ma, so this is acceleration, so this means second law, so there is a motion, dynamic. The third law, any two forces equal in magnitude, opposite direction, so this is the third law, right? Easy, simple, right? Next. Okay, so problem solving techniques. So, and then I'm going to show in a couple of the slides the generic techniques in solving any static problem, but let's focus in this example here. So the goal of studying statics, obtain magnitude of forces acting on engineering structures in equilibrium. طيب خليني اسال هذا السؤال. ابى اشوف يعني يا شباب، انا دائما احب يكون طلابي عارفين ايش قاعدين يسوون، عارفين مو بس يعني فقط حل المساله وذاتس ات. I want you to think from engineering point of view. يعني انا في نهايه المطاف طلعت القوه، ليش ابغى اطلع القوه؟ ليش ابغى اطلع ماجنتيود؟ القيمه حقت القوه هذه ليش؟ anyone؟ Why I want to figure out the magnitude of force. I explained it actually in the previous slides. I mean
دكتور تقصد باي قوه يا دكتور؟
and let's support يعني let's suppose that you have this structure, this picture in the left hand side, right? It has this force and this force, right? From this crane, right? So suppose that I wanna at the end of the day I find the force. What is the main purpose of finding the magnitude of force? يعني الحين يعني انا كستاتيك يعني statically I found the force. يعني انا وجدت القوه المؤثره
عشان لا يطيح الثقل اللي تحمله التو فورسز هذه، عشان لا يطيح العقيم اللي عليها، فتكون في حاله لازم احسبها يعني ماثيماتيكلي.
طيب احسنت، هذه نقطه. And this is one of the reasons that we find the force. I want to see that these two forces that are in balance will not affect the structure that I'm carrying on, for example, in this situation, right? Also, I want to make sure that the forces that I'm exerting on this object, for example, right, which is here, it is like represented in diagram, right? So this force that is exerting on this object will not also causing to be deformed, right? So this is in design. So I need to study the material of this one, right? Knowing that this force will exerted on it. So I need to see that force will not deflect, right? This will not deflect this part to be like this, right? So it has also another option to know the force. So I need to make this statically or equilibrium. Also, if this force exerted the strength of that material will be deflected. It means that if I see that this force is too much, it will deflect this too. So I need to put another rope here. Why? To balance. Clear? Yeah, you are right. Clear, but also we need to think also about why I'm calculating the magnitude of forces. To know that this is statically or this is in equilibrium. Also, after ensuring that, if I go to further step in another courses, so I need to see the strength of material of that object. If these forces exceeded the material strength of that material, right? The strength of that material, so it means that I need to maybe figure it out and see that this object is still in static as well as it will not deform. واضح يا شباب؟ And if you, in terms of dynamic, I'm sure that this crane will move, right? So it has like a rotational movement. So we'll take this. So I need to make sure that my movement is constant. This has acceleration. So it means the whole this action due to the wind, right? So that one will also have a forces will affect our movement. So I need to study it. So now in real case scenario, the thing is more complicated than our simplification. Clear guys؟ واضح الفكرة؟ but you take it step by step. So I simplify the problem, find the static in equilibrium, and then study later the effect of these forces on the deflection or deformation, right, or the strength of material, and then take furthermore step if you want to study the dynamics, if this moving in really huge speed, right, it has acceleration, and I can study that and see the effect of the rope, if that will break or not. Clear, guys? So this is the beauty of engineering, right? So this is the beauty of mechanical engineering. Okay? Clear? This is called analysis. This is called the engineering, like sense of design, sense of thinking from different perspective, and following the procedure. Clear, guys? Well, I hope that I'm crystal clear. So model the physical situation, and then use the graphics to represent the physical situation, and then design the crane table. Okay, and then we go to do the free body diagram. Basically we assume some, we make some assumptions, and not some assumptions فرضيات. We assume something. So for example, here we assume that the cable weight is negligible, and also we neglect the small members or distance. So we put some assumption for us to simplify the problem, right? If I don't have any data, I can assume it. You know that. Like also your assumption should be based on engineering sense, right? If you know that your assumption will change the problem, that is not assumption anymore. This becomes distractions, not assumptions. هذا حيكون مرة غيرت المسألة كاملة. Your assumption should make logic to simplify the problem in hand, and then move forward, solve based on your assumption. Okay, when you present your result to the company or to your boss or something, said, okay, this is the list of my assumptions. Based on that, I find the results. Clear? So this is the free body diagram. So free body diagram. Simple. So I have an object. I have its own weight. This is a force. The weight is force basically. And then I have the F1 for the cable 1, F2 from the cable 2. Simply. So I need now to find and finding all the dimensions, right? If I know the dimension here and the angle, right? So this comes in the next slide, right? So sketch the internal forces at the cut location, cut the body from the structure, sketch all external forces. And all the time, you have to define your convention and your coordinate, X, Y, Z. The common sense or the people prefer that X-axis is in this direction to the right, and the positive Y-axis it is on like the top or to the upward. Okay, this is positive, and here is positive Y. This is positive X. Okay, and some people in terms of rotation, after we learn moment, inshallah, they will say that the clockwise, anti-clockwise or counterclockwise it is positive. يعني هذا engineering sense of convention، يعني الاتجاهات، يعني positive convention. واضح؟ اعتقد you talk it in physics also. يعني هذا متعارف عليه دوليا. اذا ما حطيت انت people they will understand، يعني الناس يعني the people or engineer they will understand that X axis to the right is positive, Y axis to the upward is positive, and then if I have a rotation, so anti-clockwise is a positive. واضح؟ Okay, so now use a mathematical model to represent the physical situation, and then the factor addition. So we need to learn now to solve this problem. So I need to know the factor addition, know about the factor, how can I calculate the factor, how to define the components, right? And then the moment by moment, and then a particle in equilibrium in order to have sigma F equals 0. This is the end of the day that we mean by equilibrium. We solve the first Newton law or Newton's first law. Okay. Clear, guys? Simple. You find it's really simple. So in x-axis and in y-axis, component in x-axis and then component. Sorry. So x in x-axis and then sigma f y. So guys, please, يعني, if I do not write the arrowhead or the arrow in the top of any vectors, please, يعني, you should know this is a vector. You know, the force is vector, velocity is vector. Okay, so if I write, for example, velocity without an arrowhead, because sometimes I forgot when I use the right hand, it is vector. Okay, simple. So in general, in statics, we have two stages of analysis. We said that the principle we use in static is that equilibrium. So force acting simultaneously on a body do not cause the body to translate nor to rotate. So this is a generalization Newton's second law of motion. يعني second law of motion, it is just a generalization of a first law of Newton, right? يعني هي فقط يعني if you assume that there's no acceleration, zero acceleration, so that means we have sigma f equals 0. Clear? So there are two major stages in the process applying to the principle of equilibrium. So choose a subsystem, as we mentioned here before in that example of the crane that moving that object. So we choose a subsystem and represent forces acting on it, and then combining forces and studying the effects. Simple, right? So for example, here, this is really a famous example in physics. So I have an inclined surface, and then I have this object, and then I have this object is moving in that direction, right? So I need to find all the forces affecting on this object. So you know that I have a normal force, right? Because this object lying down in this surface, so this is the normal force. Okay, and then I have the weight, right? And then I have the tension. As well as if this is in constant movement, the constant velocity, so I have something called friction. Clear? So here is the forces in this direction. This direction, and here is the forces in x-axis. They have two forces, so normal forces, and here has the weight, but is a component. You know that the weight, it is in this direction. I'm sure that you are familiar with this, right? And the axis, it is in this way, right? This is x and this is y, right? So I have to find the component. So it is in xy axis. So this is why you have this direction. It is in here. So this is the component of this one, w sine theta, and this component has w cosine theta. You know that. You know that because, guys, do you know it or not? I think you know it because the inclination it has as theta. So if you are making your coordinate, it will coincidence with the inclination. Okay. So it means that the force of the weight, it is in this direction. So if I want to find the component, so I have this in y direction, it is w cosine theta, and in x direction, it is w sine theta. You know that, guys, right? Guys, do you know it? Take it home and draw it and try to find the theta for this inclination surface on the coordinate around the weight, right? Or the vector of this force of the weight. Okay, take it home and try to practice, guys, because we have more complicated problems than this. This is simple, right? Take it home and try to figure out how can you find the theta due to this inclination on the object. I'll leave it to you. Practice it at home and try to find it. It's simple. You talk in physics.
يا دكتور بس
Okay?
عندي
Sorry?
دكتور بس ما هو موضح الثيتا فين موقعها بالضبط.
موضح ايش؟ I can't hear you guys. What are you saying?
ثيتا وين بالضبط موقعها؟
Okay, okay, whatever. Okay, I told you have to get it easy, guys. This is a simple problem. Say this is the inclination as a theta. In the example, give you, for example, let's say this is 30 or 45, whatever degree. So you have to analyze this, try to find this theta where it will be here due to this object. Simple, right? You have to, if you cannot figure out where is the angles, you cannot solve the components. So because in the exam, in the real life scenario, you have this, you know, the surface, right? Suppose this is a stair or something, but you don't know how can, you have to figure it out as the engineer, right? You have to figure it out, right? You have to figure out where it is. This will be. And I will ask you to figure it out how you how I come up with this. This is the theta of the inclination. How? You have to figure it out. Because I want you to reach by your own, because we will receive in future more complicated problems. To think about it at home, I'm sure you will get it out. Okay. So because you know that this is, I said, this is the x-axis, and here it is the y-axis. Okay. How can I find the theta? How theta come from here of this inclination to here? How can I know that? This, take it all the way, right? You know, this is the inclination, so it means that if the theta has this inclination, right? So this is 90 degree between this axis. You know that any axis has 90 degree between the two axes, right? But this is now tilted. So it means now, if this is the force in this direction, so where is the theta? Theta is here or here. You know that. يعني لما يكون عندك درستوها في الرياضيات يا شباب، لما يكون عندي مثلا ان شاء الله انا I put it in the list of the يعني عندك هذه الثيتا it will be equal to this theta, right? يعني هذه شيء بيسكس في الرياضيات، تريجومتريك، يعني هذه اشياء اللي هو المثلثات، علم المثلثات وعلم الزوايا، يعني easy. If you cannot really figure out that, really urge you this thing. Okay, clear guys? I just gave you hint. I want you to practice at home. Clear? And this is really simple. Good. I hope I answered your question, Abdul Rahman, or at least give you a hint. Right? So two stages of analysis. So now let's see. Okay, yeah, it's easy, but I know that sometimes we forgot it, right, from time to time, because you not really practice all the time. But that's fine. That's fine. Yani if this question raised up, it's good just to go back, review it, and do practice. A lot of problems. How can I figure out the angles of this inclination if I have this object in this way? It's good to practice. Guys, I really advise you from the beginning of the term, like as much as you practice, right, as much you become more like good engineer, and more يعني you score A+ actually in this course. So you have to expose yourself to different problems. Okay, so basically here the process of solving a problem in static, as you mentioned, we choose to focus on a block or the bodies or whatever. And we draw by diagram, and we identify all the forces acting on a block and represent the forces in drawing. And then, so we're combining forces, sigma F, studying the effect, Newton's law, by saying that there's no acceleration, so A is 0, so sigma F equal. So I found that in equilibrium, sigma F equals 0. If there's acceleration, so this is dynamic, but this will not study it here in statics. This is dynamic. Okay, so we are here. Simple. So also more details in mechanics. And why statics belongs to mechanics? If you look at, so we choose the body as we mentioned, define the forces after drawing the fluid diagram, and then combining the forces, you said sigma F. So we say sigma F in equilibrium, that means sigma F equals 0. If not equilibrium motion, sigma F equals ma. Sigma F equals 0, that means either static, right? This is a rigid body, as I mentioned, or mechanics of material. This forces will deform or change the shape of that object. Clear? In terms of motion, we have dynamics. So also this is still rigid body, but it has acceleration. And then fluid dynamics or fluid mechanics, this is a fluid, right? This is a matter of state of the matter. It's not solid, it is good. This is just also another summary. So now also, like the big picture of statics, so typically the process is analysis, is an iterative process where we choose the subsystem and represent the force as I mentioned on the diagram, or free body diagram we call it, only to define and only to find it possible to determine the desired force. And then choose alternative or additional subsystem. And also with experience, inshallah, later on after you expose to yourself different you'll find that you have a common sense and finding the forces with only looking to the system, right? So basically, we have two blocks. The blue one, it's choosing the subsystem as we mentioned, representing the forces acting on the body. So it means drawing the provide diagram. So the cycle of this one, it shows the system represented with the interaction of two forces or whatever, with the effect of external forces on that part. Also choose alternative additional subsystem if there is two systems that outer system will affect that second system and also will exert a force on that one. So I need to include the effect of that forces, right? And then that goes to the yellow block, so which is combining forces. Now solving, I need to see sigma F. Right? Generic scenario is MA. Right? But if there is no acceleration is 0, so it means it's possible to determine the desired forces. If yes, so imposing and solving equations of motion or equilibrium. 0 in equilibrium, motion, there is acceleration. Easy. No, I need to get back, finding another alternative subsystem and solving and choose the external force and go on. Just a quick review for you, trigonometric, right? You know that the polar notation is simple. So this is 0 degree, 90 degree, 180, 270, 360, right? The right angle triangle, the Pythagorean theorem, هو قانون فيثاغورس, have hypotenuse, opposites, and adjacent, right? This is the inclination of that. Remember, it's really important to learn about this. You know that sine theta, it is the opposite divided by the hypotenuse المقابل على الوتر. Cosine theta is المجاور على الوتر. It is the adjacent over the hypotenuse, and tan theta, it is المقابل or opposite على الadjacent. Clear? And this is the generic equation, right? We said that the hypotenuse طول الوتر تربيع equal مجموع طول الأضلاع الآخرين تربيع. Easy, you know this. Math, simple math. Now the complementary angles, see, we know that this any axis xy, for example, they are in a 90 degree. So if this line, so this is a complementary. If I know, for example, if I know this, for example, is a 30 degree, for example, let's say, and I know this is here and this in between, I want to find B, you know, simple, 90 degree minus 30, it gives us 70 degree. Easy, this is complementary angle. Supplementary angle, so 180, right? So I know that if I know B, the angle here, let's say this is 30. So I want to find A, so it is 180 minus 30, and I can find the supplementary angle. Easy, simple. Here is a triangle, right? You know the summation of all the angles inside any triangle is 180. It's simple. We know that the labeling, this is A, B, C, this is how we label it, right? Here is the parallel with the cross section, with the cross line. As I mentioned, you know that if I want to figure any, see this angle, it is equivalent to this, right? And this angle, it is equivalent to this angle. You know this, right? So this is called parallel with the cross line. Okay. So this is how you find the angles. Here is the law of cosine. Is important. Also the law of sine. You know this, right? So whenever you have known, it's called side angle side. So if I have two sides known and one angle, I can use law of cosine. So if I have one angle and the sides, so I can find, if I know two angles and one side, I use those signs. Clear? Again, if I have two sides, one angle, I use law of cosine. If I know two angles and one side, I can use those signs. Clear? Simple, right? Simple. Okay, so this is also now in details for the vectors. As I mentioned, has a magnitude direction. As I mentioned, we can define the vector in any space. For example, if I want to define velocity with a vector as a vector representation in the paper, in two-dimensional, in this case, in the paper, because paper is 2D. Like, but in real life, we have a 3D. So we have X, Y, and Z. So X, Y, and Z. Okay, guys, are you with me? Hello, guys, are you with me?
ايه دكتور معك دكتور.
Okay, so far so good. Okay, we have only 3 minutes quickly. So it's really important also to know the point of application. Okay, nice. It's important to know the point of application of that force, for example, here. So that, okay. Can anyone tell me before we go to this point, what does this negative velocity here mean? Or this negative vis vector here means? So whenever I have negative vector, what does that mean?
عكس اتجاه V.
أحسنت. It's opposite to the direction. أحسنت. It's opposite to the direction. Okay. And could be also if I have like opposite direction equal magnitude, that means the third law of Newton. So this for example, this particle, it is in not motion. This is not in motion. But if it is this one in this direction and that one is in negative direction, if this, let's say negative V is greater than V, and that direction, say this is in the left hand side and this is in right hand side, so that means the motion will take place in this direction. Okay, so the point of application, for example, for the forces, it is really important to know where is the location or where is the point of application of that force or that vector in general, right? So that one, for example, I have here force, I have here moment. So it is not the same as if I have a force in this location of this structure or of this column, for example, of this structure, and the moment is in this direction. Clear? And you know this, actually, basics. And similarly, if I have the vector, it is like a slight vector. It means that the vector, it has the effect on the same line of the direction of that vector. So whenever, if I affect here on the object, is the same, exactly the same when I affect the object from the middle. Again, if I have the object and I have this vector, the sliding vector, it means that if I have this direction, this is the again. Let me be crystal clear. So for any vector, so I need to know the point of application, the direction, the sense, the magnitude. Repeat it again. Let me be clear. For any vector, so I need 4 things. I need this first one, point of application. Second one, they call it direction. Third one, called sense. Fourth one is magnitude. A first one, we have been discussing it just a while. Second one is direction. Direction, it means to define the line. Is it in x-axis, y-axis, or z-axis, or with an angle, whatever. Since it means the direction, it is the arrow. Is it upward, downward, forward, backward, with any angle in that direction. Clear? يعني the arrowhead. Good, guys? And then the magnitude, you know that. القيمة المطلقة. واضح الفكرة? This is really important. Okay, for this example, back to this example. So now this is the we have three different type of vectors. We have free vector, we have fixed vector, and sliding vector. For example, here sliding vector, so the effect of it, if it's still in the same line of action, they call it line of action or the direction. So that no matter if I apply in this location or I apply in this location, if it's still in the line of action, so this vector called a slide vector. Here, let's be more specific. Maybe if I go to next slide, be more, yes. So this is a vector. Have free vector. So this when we have the objects moving or rotating, so it can be defined by magnitude and direction. So there it is not confined or associated with the unique line in space. Clear? This is called free vector, like displacement. If I have vector object A moving in this direction up to B, right? So I can define them with this is called a free vector. So displacement is a free vector. Sliding is for a force. Force could be if a force is affecting in here and is sliding and affecting another here. So also it has the same effect. If they are equal in magnitude, equal. But I need to also take an account for that. If they are different force, different magnitude. But if it's still the same magnitude, if I have one force, I'm affecting the body from here or affecting the body over here, it has the same effect. If it's still they have the same direction, same magnitude, the same line of action. Clear? Okay. A fixed vector is an action associated with unique point of application. This is we call the fixed vector. If the vector is affecting in here, is not same as the vector affecting like this in other location, other position. So this completely two different vector, and they have different point of location and different direction, different magnitude. Clear? So the body will receive different effect. لها تأثير آخر. هذا called fixed vector. أتمنى تكون واضحة يا شباب. Clear? Okay, بارك الله فيكم. Okay, now have some principles are really important in mechanics. One principle called parallelogram law. يعني هو قانون شكل متوازي الأضلاع. بمعنى if I have a three vectors, one vector in this direction, v2, and the v1 is in this direction, I can, without affecting the dimensions or directions, I can bring the end of one of them to the end of the second of one of them, bring it like as you can see in the second picture, right? So now I can find the resultant, which is v. Okay? Or I use, can anyone tell me what does that mean? This is another law. Let me see your knowledge. It had the same effect. So either to take end to end, so this is called parallelogram law. Condition should be for a free vector, as I'm highlighted here. Okay, but also I can use head to tail idea. So what does that mean? Head to tail idea of bringing the vector. So I can bring this one here, move it here, saving حفاظا على الدايركشن، حفاظا على الماجنتيود. بس اقربه هنا وابدا احطه وابدا اشوف الريزلتنت. هذا لها اسم اخر، اللو هذا قانون، ايش اسمه يا شباب؟ I'll leave it to you. I'm gonna ask you next lecture. You are supposed to know this from physics. Anyone know it? This is called the parallelogram theorem. If they are in 90 degree, between the two components. Let's say, for example, like this, if V2 is like this, so we still have the same. This is called rectangular components. V2, V1, right? So that is we have discussed it in the previous slides, right? But if I'm using this, is if you pay attention, Barolin theorem, they have two factors, they have three factors, right? But tail to tail. So the end of this one comes with the end of this. But here, if you notice, we have head to tail. This called what? Anyway, I leave it to you. I'm gonna ask you next lecture. Generally, we said that the adding of the two factors, three factors, so it takes this shape, but not necessarily that the magnitude, we can add them like this. So the total resultant, the magnitude of the resultant is it not necessarily it is equal to the magnitude of V1 and V2. Clear? This is really clear. We are adding factorially. يعني بطريقة المتجهات. We are not adding arithmetically, algebraic يعني value. Here we are adding factor. Factor, it has like a special way of addition and subtracting. Clear? It's not adding 1 plus 1. I hope that's clear, and you know this actually. So if they are not three factors, you can sum them and them if they have the same point of the application. What does that mean? This note said that احنا قلنا parallelogram law is only concentrated with a free factor, but they suppose that they are not free factor, but they have the same point of application. So this one force here, and here another force. So I can still add them. Find the component of this one, find the component of this one, right? And then I find the resultant. Clear? So, but as shown here, so parallelogram theorem, again, this is more explanation. So V1 and V2 are called components. You know this, simple. So here, as mentioned, rectangular components because they are 90 degree. Okay, simple. And this is what I mentioned: a unit vector. Any vector can be represented as the magnitude times the unit vector along to that axis. Clear? Simple. I'm just reviewing with you here. Here's the three-dimensional case. Simple, as I mentioned, IJK. Simple. And here is a more generic way of defining the vectors in terms of the directions cosines. They call direction cosines. Okay. If L is cosine theta along the x-axis, the M it is the direction cosine along the y-axis, and N is the cosine direction on the z-axis. So I can define the V, the component in x-axis, as if it is L multiply the magnitude, right? You know this is something logic, right? Because this is how you define the component. This is an x-axis. In y-axis is M divided V, which is cosine, and so on. Okay. Well, at the end of the day, L squared plus M squared plus N squared equal 1. This is you have to specify the condition. Clear? So this is called the direction cosines, which is here. Ly, Lm, Lmn. Read it in the chapter 1. If you read it, you find it's really clear. Okay, and you have taken it in the physics. Here's the principle, another principle called the transmissibility. Right? Suppose that they have external forces on rigid body, and the force is transmissible, right? Where a force may be applied at any point in a line of action without altering resultant effects of external to the rigid body. So this is called the transmissibility. يعني هذه قوة يسمونها يعني transparent force. يعني we're not actually, we'll see it inshallah in details. Okay, what we mean by transferability. But whatever I want to say here, so let's say that you have concurrent force. That means the two forces acting in the same point of application. So I can add them sectorially, right? And if they are non-concurrent, so if they are sliding vector, so I can add them to bring and see where they are contacting, and then I can add them vectorially. Okay. Here a problem. Okay. Oh, sorry, I passed the time, guys. No one warned me. Sorry, guys. So I already. So I will leave this a simple problem for you. So we have two vectors here. Is asking you to determine the magnitude, right? And then determine the angle, and finally write the x vector in terms of ij, right? And determine the vector difference. Easy. This is good practice for you to refresh your mind. So I leave it to you. You have the answer here. It's really laid down for you. Just before you look to the answer, try to solve the by your own. So this is also one of the example in the chapter 1 in your book. The book I'm talking about, it is for the author Miriam and Craig. Okay, Miriam and Craig. The 6th edition. I uploaded to you. I upload the ebook, the soft copy, and the Blackboard. You can find it. Okay. So we have here the problem. You can solve it by yourself, and we are done with the first lecture. Any questions, guys? Sorry, I passed the time. Sorry, guys, I didn't watch time. Any questions? Guys, hello, can you hear me? Okay, Jazakumullah khair. So I'm gonna take the attendance from the Blackboard. No worries. Any questions? Simple, simple. يعني inshallah, if you do practice from now, whatever I'm saying to you to practice, it's better for you to be in same page in the following chapters and so on. Because most of the introductory chapters is just a review for you guys from physics 1. Okay? Good? سبحانك اللهم وبحمدك أشهد أن لا إله إلا أنت أستغفرك وأتوب إليك. So I'm done. Thank you. جزاكم الله خير على الحضور ونراكم إن شاء الله next week. Good. So I'm gonna stop the record.